Good morning, students. Students, this lesson is of class 9 for the subject of mathematics, topic chapter 10 Pythagoras Theorem and chapter 13 chord properties of a circle, and is being submitted to you on 24th May 2021. Students, in this lesson, we will discuss about the theorem, that is Pythagoras Theorem. Then we will do questions based on Pythagoras theorem, and then we'll discuss chapter number 13. So now children, let us start today's lesson. The theorem is named after a Greek mathematician called Pythagoras. Pythagoras theorem is basically used to find the length of an unknown side and angle of a triangle. I repeat, children, Pythagoras theorem is used to find the length of an unknown side and angle of the triangle. Okay, so now let us read the statement of Pythagoras theorem. Now, children, if we are given with a right angle triangle, then the square of hypotenuse side is equal to the sum of square of other two sides. Okay, so what is your Pythagoras theorem? You can see in your picture, like if you have a right angle triangle, then the square of hypotenuse is always equal to the sum of square of other two sides. Now, children, suppose in this triangle ABC, angle B is 90°. So according to the Pythagoras theorem, hypotenuse, that is AC square, is always equal to the square of two sides, perpendicular and base. So here you can say that it is AB square plus BC square. I repeat, here hypotenuse is AC, so you can write it AC square, which is equal to AB square plus BC square. Children, this is your Pythagoras theorem. This is a relation between three sides of a right angled triangle. Is it clear, children? Now let's read the converse. Converse means reverse. So now, children, if in a question it is given that the square of one side is equal to the sum of square of other two sides, then the triangle is a right angled triangle. Okay, let's understand with the help of this figure. So when this is a triangle ABC, and suppose it is given that AC is square is equal to AB square plus BC square. It is given, already given. So it means, according to the converse of the Pythagoras theorem, you can say that this must be a right angle triangle. So what you can say, that triangle ABC is a right angled triangle. So here AC is your hypotenuse, AB and BC are the other two sides. So it must be angle B. It means your right angle is at B. Is it clear, children? So converse and Pythagoras theorem. So now, children, let's prove the Pythagoras theorem. Children, we have just discussed that what is a Pythagoras theorem? Pythagoras theorem means the square of hypotenuse is equal to the sum of square of other two sides. Okay, children? So let us prove it. Now we have taken a triangle ABC. Now, children, you can see that this is triangle ABC, and you can easily see that it's a right angle at B. Okay, this is your right angle B at B, 90°. Okay, here AB is equal to C length. AC length is B and BC length is A. Okay, children, these are the length. Fine. So what is given in the question? Triangle ABC, where angle B is of 90°. So your AC is the hypotenuse. And children, what you have to prove here? You have to prove the Pythagoras theorem. That is, AC square is equal to AB square plus BC square. So now, children, to prove this theorem, we have to do a construction. So let's see what we have done in this. Now children, you have a triangle ABC. Now I'm going to make here. This is your triangle ABC. And now we will extend BA to D. Okay, we will extend BA till D such that this BC is equal to AD, means though both things should be of same length. So children, here we have written A, so this is also A. Okay, this is my first one. Now next construction is at point D, I will draw a 90-degree angle, means a perpendicular. And the length of this perpendicular will be equal to AB. Okay, so here AB is C. So this is also your C. These two are my construction. One, I have produced BA to D, and then I have drawn a perpendicular to D. Okay, and now children, you have to join A to E, and then you will join E to C. Okay, this is the construction. Now children, let's do the proof. Now with this figure, children, you have two triangles, even three. So let's take these two triangles, that is triangle ABC and triangle ADE. Now children, we are going to prove them congruent. So in triangle ABC and EDA, you can easily see that BC is equal to AD. Okay, and AB is equal to ED. You know why? Yes, because by construction, because we have constructed. And angle B is equal to angle D. Can you tell me why these two are equal? Yes, because they both are of 90 degree. So children, you can see that both the triangles are congruent. So therefore triangle ABC is congruent to triangle ETA. Okay, so these two triangles are congruent. Okay, so if these two triangles are congruent, you can see that say that AC is equal to AE. Okay, what can you say? AC is equal to AE. Okay, and angle BCA is equal to angle TAE. Okay, let me say again that angle BCA is equal to angle EAG. Why? Because by CPCT. Okay, children. So now our first thing is over. Now, children, consider triangle ABC. Do you agree with me that the sum of all the three angles is equal to 90 degree? Okay, so children, you can say that angle CBA plus angle BCA plus angle BAC. The sum of all these three angles is equal to 180 degree. Okay, the sum property, the sum of all the three angles is equal to 180. So now children, if one is 90, so the sum of these two angles is also equal to 90. So from here, what we get it, that angle BCA, okay, angle BCA and angle BAC is equal to 90 degree. Okay, so the sum of this and this is equal to 90 degree. Okay, and children, you know that your angle C is equal to angle EAT. We have just proved that by CPCT that angle C is equal to angle EAD. So instead of this, you can write angle EAT plus angle BAC, which is equal to 90 degree. Okay, so if these two sums is 90 degree, then this is also 90 degree, because in a straight line linear pair, the sum, if in a straight line angles, the sum is 180. If two sum is 90, so definitely the angle CA is also 90 degree. Okay, children. So now your main thing is over. Now you have to find that area of trapezium. Now children, this become an trapezium because here BC is parallel to ED. This is parallel to ED. Okay, and this is because angle B plus angle D is equal to 180 degree. That's why BC is parallel to ED. So children, this is your trapezium. Whole figure is a trapezium. So here you can say that area of trapezium BDEC is equal to, because there are three triangles in this, so you can say that area of triangle ABC plus area of triangle CAE plus area of triangle ADE. Okay, so the complete figure is of three triangles, so you can add all the three areas. We'll get the area of trapezium. Now, children, you know that area of trapezium is half sum of the parallel sides. Parallel sides are A and C. It's A plus C. Then multiply by its height. The height of the trapezium is, or distance between the two parallel sides, that is A plus C. So it is this. Now children, the area of trapezium is equal to sum of all these three. Okay. So what is the area of the first one? Can you tell me what is that? It is half base into height. So it is half AC plus. What is the area of the second one? Because this is also 90, half base into height. So half B into B, that is B square. Now the third one, half triangle. Again, it's a right angle triangle. So half A into C. Okay, children. So you get this as an equation. Now solve it. It is half times A plus C whole square, which is equal to half. If you take out common, it will be AC plus B square plus AC. Okay, children. Now let's move on to our theorem. Now, children, when you apply the formula here, A plus C whole square, you can cancel it out. Here, half and half will be cancelled. And A plus C whole square will be A square plus C square plus 2AC, which is equal to B square plus 2AC. And now you can cancel 2AC and 2AC. And here you will get B square is equal to A square plus C square. And children, here the length B is actually AC, so it is AC square. Length AB is your A, so you can write AB square, and C is your BC square. So this is our proof of the theorem. And so you can say that the hypotenuse square is always equal to the square of sum of square of other two sides. I hope children you are clear with this theorem. Now let's practice the questions based on Pythagoras theorem. Now let's look at the question number 1. Now children, in this question, triangle ABC is given, angle C is 90 degree, AB is given 25 centimeter, AC is given 7, and you have to find the value of BC. So according to the Pythagoras theorem, in a right angle triangle, hypotenuse square is always equal to the sum of square of other two sides. So here AB square is equal to AC square plus BC square. Children, here AB is 25 square and AC is 7. So you can write 7 square, and BC you have to find out. So 25 square is 625. 7 square is 49. It will go that side. It will become minus. And next step, 625 minus 49 is 576, which is equal to A square or BC square. The final answer of A is square root 576, that is 24 centimeter. So children, what is the third side of the triangle? 24 centimeter. Okay, now let's move on to question number 6. Now, a ladder 13-meter long rests against a vertical wall. If the foot of the ladder is 5 meters from the foot of the wall, find the distance of the other end of the ladder from the ground. So now children, here we have a wall. We have considered AB is the distance of the other end of the ladder from the ground. So AB is our wall. AC is the ladder leaning against the wall, and BC is the distance of the ladder from the wall on the ground. Okay, so what we are given here, we are given with the distance of the ladder, that is 13 meter. We are given with the distance of the ladder from the wall on the foot on the ground, it is 5 meter. Now you have to find the distance AB. Okay, so apply the Pythagoras theorem here. It will be AC square, because it is hypotenuse, is equal to AB square plus BC square. Children, here AC is 13 square. AB is not given, we have to calculate, and BC is 5 square. So just do it. 13 square is 169 minus 25, which is equal to AB square. And here you will get 144 is equal to AB square. And finally, AB is equal to square root 144, that is 12 centimeter. So now children, what is the distance of the ladder from the top? That is 12 centimeter. Okay, children, I hope you are clear with this question. Now, children, you may pause this audio or video for the next 3 minutes and write the following answers of the question. Now, first one is state Pythagoras theorem. Then, if in a triangle PQR, PQ square is equal to QR square plus RP square, then what can you say about angle P plus angle Q? Now, children, 3 minutes are over. Now, let's discuss the answer of these two questions. Pythagoras theorem. In a triangle, the square of hypotenuse is always equal to the sum of squares of other two sides. Now, the second one, in a triangle PQR, if PQ square is equal to QR square plus RP square, then angle R is 90 degree, because according to the converse of Pythagoras theorem, then if angle R is 90 degree, then angle P plus angle Q must be equal to 90 degree. Now children, let's discuss question number 10. Now children, in this it's given that rhombus PQRS, side PQ is given 17 centimeter and diagonal is PR, that is 16 centimeter. Calculate its area. Now children, you know that area of the trapezium is half of their half multiply with the diagonals. Okay, half d1 into d2. So one diagonal we know, we have to find the other diagonal. So let's see children, if PR is here 16 centimeter, then OP is 8 centimeter, because the diagonal of rhombus bisect each other at 90 degree. Okay, so children, here we got a right angle triangle, that is POQ, where OP is 8, PQ is 17. So easily we can find OQ. Okay, children. So let's see. It's PQ square, because it's a hypotenuse, is equal to OP square plus OQ square. Okay. So PQ is given to you 17. OQ, you have OP is given 8 square, and OQ you will find out. So 17 square is 289 minus 64, which is equal to OQ square. Okay, so finally you will get 225 OQ square, and your OQ is equal to what? It's 15 centimeter. Is it clear, children? What is your OQ? 15 centimeter. So now children, if OQ is 15 centimeter, so the length of the diagonal will be double of that. So SQ is equal to twice 15, that is 30 centimeter. So now children, you are having both the diagonals with you. So you can find the area of rhombus, that is half times the product of two diagonals. Okay, so one diagonal is 16 and another one we just calculated 30. So just cancel it. You will get 240 centimeter square. Okay, so what is the area of the rhombus? That is 240 centimeters square. Now children, let's move to the question number 15. Now children, in this a triangle is given to you, triangle ABC, in which angle B is 90 degree. So now children, just have a look on the bigger triangle, that is triangle ABC. This is your AB, this is your length BC, and this is your AC. Okay, children, and your 90 degree is at angle B. Fine. And D is the midpoint of BC. Children, D is the midpoint of BC. It means BD is equal to DC. Fine. Now you have to prove that AC square is equal to AD square plus 3 times CD square. So now children, what you will do, first you will take because we need AC and AD. So let's take a bigger triangle first. That is in triangle ABC, angle B is 90 degrees. So you can use the Pythagoras theorem. That is AC square is equal to AB square plus BC square. Okay. Now similarly, you can take the smaller triangle, that is triangle ABG. In this also, we can use Pythagoras theorem, and it is AD square is equal to AB square plus BD square. Okay, children? So now you have to subtract these two, and when you subtract it, AC square, left hand side will become AC square minus AD square, and AB square and AB square will be cancelled, and here you will get BC square plus BD square. Okay, children? And you know that here BD and CD are equal. You know that BD and CD are equal. So children, instead of BD, you can write CD. Okay, what you can write here? It's minus, and BD is CD because they are equal, and BC is twice of CD, double. So it will become twice CD square. Okay. Now children, you will get 4CD square minus CD square. You will get answer as 3CD square. Okay. So it means AB square minus AD square, AC square minus AD square is equal to 3CD square. So finally, you will get AC square as AD square plus 3CD square. Now, children, you have to prove the second one. In the second one, you have to prove that BC square is equal to 4 times AD square minus AB square. So now, children, in triangle ABD, you know that AD square is equal to AB square plus BD square. And now, children, here you know that BD is half of BC. Okay, AD is what? Half of BC. So instead of BD, you can write half of BC whole square. So now here it will become AB square plus half times BC square. Further, AB square plus BC square upon 4. Take the LCM, it will become 4 times AB square upon 4 plus BC square. And in the next step, 4 will go that side, and it will be 4 times AD square is equal to 4AB square plus BC square. Fine. And when you take out the common, you will get BC square as 4 times AD square minus AB square. Okay, children. So please learn the Pythagoras theorem and try all the questions based on the Pythagoras theorem. Thank you, students.